This is Mrs. Wainwright's math class, chapter 6, 7, 8, Pkt E, lesson 9, problem solving with the work backwards strategy. Our learning target today, by the end of the lesson, you should confidently be able to say, I can use the work backwards strategy to help solve problems with fractions that involve addition or subtraction. The big question here is, how do you know when you have a word problem that you need to use the work backwards strategy? Well, this is the very important page to study. When given the total in a word problem, so they give you the total amount or the total whatever it is, and they give you one or more parts of the total, and you're asked to find that last part or a missing part, then it's helpful to use the work backwards strategy. As a review from previous chapters, here are the work backwards steps. First thing we do is the setup. So we find the letter for the unknown item, that goes first. You put everything else you know, whether it's adding, subtracting, whatever you need to do. Then you put an equal sign, and the given total goes after the equal sign. Once you have your setup, you'll work backwards. You'll go in the opposite order. You'll do the opposite operations, and the unknown letter will go at the end. Finally, last step is to solve. So you'll solve the work backward problem to find the unknown letter. And that's our work backward steps. Let's take a look at example number 1. The Diaz family is cross-country skiing the Big Tree Trails, which have a total length of 4 miles. Yesterday they skied the 7/10 mile Oak Trail. Today they skied the 3/5 mile Pine Trail. If they plan to ski all of the Big Tree Trails, how many more miles do they have left to ski? This is a word problem, so let's go back and see what the question is asking us. The question asks, how many more miles do they have left to ski? Let's see what I know. I know that they have a total length of 4 miles. I'm starting with the total. That's interesting. What else do I know? I know that yesterday they skied 7/10 of a mile on the Oak Trail, and today they skied 3/5 of a mile on the Pine Trail. So the question gives me the total, gives me small amounts, and asks me how much is left. That tells me this will be the work backward strategy. Remember, the work backward strategy has 3 steps. The first step is the setup. I like to label it SU. You do need to label all the steps with letters or words, your choice, for the work backward if you want to be considered for any partial credit. So the first step is the setup, SU for setup. For work backward, what do I do for the setup? First, I find the unknown, and that's in the question. How many more miles do they have left to ski? I'm looking for how many more miles, so I'm going to choose the variable or letter M. The variable or letter can be any letter you want it to be. I like to choose one that kind of goes along with the word that I'm looking for. Okay, so I found my variable in the question. I cross it out. Next thing I'm going to look for is the total. That's going to go at the end after the equal sign. And if I look back at my question, the bright blue says I have a total length of 4 miles. So I'll put an equal sign and 4 since the total goes at the end after the equal sign. I'll cross that out in the question. Now I fill in everything else I know. I know that yesterday they skied 7/10 of a mile. So we have the unknown miles, and we have the 7/10 that they skied. That's going to be a plus because and will be a plus. Cross that out in my question. And today they skied 3/5 of a mile. So I'll add 3/5 onto that. So it's the unknown, 7/10, 3/5 all together equals 4. That's my setup. Cross out that last 3/5, and now I'm going to move my setup to the next page so that I have more room. So after the setup, the next step is work backward. I will abbreviate that as WB because remember, if you want to get any partial credit, you need to label your steps. Work backward is exactly as it sounds. Take the last number, the number at the end, since I'm working backwards, in this case it's a 4, write it down. Once I write it, I cross it out. Next I get to the equal sign, and that's the one thing that stays exactly where it is, just moves down, move it down, cross it out. Then when I get to the numbers, I look for the operation in front of the number as well as the number itself. I circle it. So plus 3/5, opposite order, opposite operation, will turn to minus 3/5. I used it, I cross it out. Next operation in number is plus 7/10, backwards order, backwards operation, will be minus 7/10. I used it, I crossed it out. Next I get to the variable, and the variable always goes after the equal sign. So I will put the M and cross it out. I am finished with my work backward. I'm ready for my last step, which is my solve step, so I'll label it with an S. Now I'm working with fractions, and I'm subtracting them. And I know the rule is to add or subtract fractions, the fractions must have common denominators. So I'm going to focus in on the denominators of my fractions in the work backward to see if they're common. This denominator is 5, and this one is 10. They are not common. So I'm going to need to find least common multiple, least common denominator of those denominators to make common fractions. So I'll write LCM, LCD. My larger of them is 10. I'll write that first, and then the 5. Go through the 10 times tables. 10 times 1 equals 10. When I go through my 5 times tables, do I say 10? Yes, I do. So 10 is my LCD, which will be my new common denominator. Now let me go back to my problem and see which fractions I need to change and which fractions already have that common denominator of 10. So I have 3/5. I'll need to change that one. Let's write down 3/5 with my window box, my new fraction bar, and the new common denominator, which will be 10. Do I need to change 7/10? No, because that already has a denominator of 10. So all I need to do is change that 3/5. Okay, so let's do it. 5 times what is 10? 5 times 2 is 10. Whatever I do in the bottom of the window box, I must do on the top of the window box. So I'll say times 2. 3 times 2 is 6. So 3/5 changes to 6/10. I'll go back into that work backward step, cross out the 3/5, and right underneath it, I'll write down the new fraction with common denominators, which is 6/10. Now I'm ready to solve, and let me just rewrite this new problem to make it neater. 4 minus 6/10 minus 7/10 equals M. So I'll move my problem over to solve. 4 is a whole number, minus 6/10 is a fraction. That should go in the fraction column. Okay, I used the 4, so I'll cross it out. I used the minus 6/10, I'll cross it out. And let me go ahead and solve this problem. Fractions column. If I have no little pieces, can I give someone 6 little pieces? No, so I have to borrow. Cross out the 4, make it a 3. What am I going to turn that Hershey bar that I took away into? Well, the denominator on the bottom is 10, so I'll turn it into 10/10. Now I can subtract. 10/10 minus 6/10 equals 4/10, because 10 minus 6 is 4. Denominator stays the same. 3 minus nothing equals 3. Okay, go back to my solve. The next step that I have left is minus 7/10. So I'll say minus 7/10 in my fraction column, cross it out, and I'm ready to subtract. Okay, fraction column. If I have 4/10, can I give you 7/10? No, because I only have 4 little pieces. I can't give you 7, so I'm going to need to borrow. Cross out the 3, that becomes a 2. I'm going to take that 1 Hershey bar, break it into 10 pieces, right? Since my denominators are 10, I'll break it into 10 pieces. I have all of them, which is 10/10. So on the top I had 4/10, and I'm adding 10/10 to it. Let's rewrite our new number. Whole number is 2. 4/10 plus 10/10 equals 14/10. Bring over the other number, which is a subtract, 7/10. And now I'm ready to go ahead and do the math. Denominators are the same, so I have to do 14 minus 7 equals 7. Denominator stays the same of tenths. 2 minus nothing equals 2. Go back into my solve, and what I have left is equals M, so I'll write that next to my answer. So I have 2 7/10 equals M. This was a word problem. Let's go back to the word problem to put my final answer of 2 7/10 in. The final question says, how many more miles do they have left to ski? So I'll say they have 2 7/10. It's right, the unit's right in the question. Miles left to ski. And that's my final answer. Please stop the video and complete worksheet number 1 right now. Let's take a look at example number 2. I wrote this when I had a student, Christina, who had gotten a new kitten. Christina spends 1/6 of her weekly allowance on cat toys, 1/4 on a cat collar, and 1/3 on cat food. What fraction of her weekly allowance is left? Well, again, it's a word problem. Let's take a look at the question. It wants to know what fraction of her weekly allowance is left. I want to know what amount is left, and I see all these other fractions, but I don't see a total. This happens frequently in problems with fractions. It doesn't give you a total, and you kind of scratch your head and say, I don't know how to solve this problem. But let's think about it. If there's no total and all you see are fractions that are less than 1, well, fractions are less than 1, so all the parts together might equal the total. And in this case, we're talking about her allowance, so the total is really her whole allowance. It doesn't tell us how much her allowance is, but it gives us all little fractions or little parts of her allowance. So really, it's talking about her one whole allowance, and these are all little parts of that one whole. Remember, one whole is the digit 1. So it doesn't show us sometimes in a fraction because it's really the whole, which is the number 1. Okay, so I know the whole allowance is the 1. Let's see what else I know. I know that Christina spends 1/6 of her allowance on cat toys, 1/4 of that whole allowance on a cat collar, and 1/3 of that whole allowance on cat food. I know the total is 1, I have all these little parts, and I need to know the leftover part. That tells me that this is a work backward strategy. First step for work backward is our setup, and we want to label our step, so I'm going to label it SU. Remember, for the setup, we find the unknown. It says what fraction of her allowance is left. I'm going to choose to use an F for fraction. You can use anything you want, but that's what I'm going to use. Cross it out since I used it. What else do I know? I need the total at the end, and we said the total is 1 whole, or 1. My total is 1, so I'll put an equal sign and a 1 at the end. What else do I know? I know that Christina spends 1/6 of the allowance. She has a total. She spends a certain fraction and another certain fraction and another certain fraction. I'm going to add all of those things together, all the things that she spends. So we have the fraction that we're missing, which is the F, plus the 1/6 that she spends on her cat toys, cross that out, plus the 1/4 that she spends on her cat collar, cross that out, plus the 1/3 that she spends on the cat food, and cross that out. My setup is now complete. We have my F, the fraction that's unknown, plus 1/6 plus 1/4 plus 1/3 equals the 1 whole allowance. Let's move to the next page where we have some more room to finish this up. Okay, so the next step after setup is work backward. Let's label it, because if we want to get any partial credit, we have to have our labels. WB for work backward. Okay, work backward means exactly what it says. We start at the end. My whole number is the 1. I'll write it down, cross it out. Equal sign is the only thing that stays where it is, so I bring down my equal sign, cross it out. I have plus 1/3, opposite is minus 1/3, cross it out. Plus 1/4, the opposite is minus 1/4. Cross it out. Plus 1/6, the opposite is minus 1/6. And now I have the F, which the variable, the letter, goes after the equal sign. My work backward is done. I'm ready for my solve step. But I am working with fractions and subtracting fractions, and I know that if I'm going to add or subtract fractions, I must have common denominators. So let's take a look at my denominators and see if I need to do anything to them. My denominators are 3, 4, and 6. They are all different, so I'm going to find the LCM, LCD of all of those numbers. Largest is 6, then 4, then 3. Go through my 6 times table. 6 times 1 is 6. When I go through my 4 times tables, do I say 6, 4, 8? Nope. Put a slash through the 3. What comes after 6? 12. When I go through my 4 times tables, do I say 12? 4, 8, 12. Yes, I do. When I go through my 3 times tables, do I say 12? 3, 6, 9, 12. Yes, I do. So my LCD is 12. That will be my new common denominator. Let's take a look at one fraction at a time. The first fraction has a denominator of 3. I'm going to need to change that to 12. So I'll write 1/3 with my window box equals, and my new common denominator of 12. Let's go ahead and figure it out. 3 times what equals 12? 3 times 4 equals 12. Whatever I do on the bottom, I must do on the top. So I'll say times 4, and 1 times 4 is 4. So I'll go back and I'll cross out my 1/3. I'll change it to the new fraction 4/12. Let's take a look at my next fraction that has a denominator of 4. I need to change it. So I'll write 1/4 with my window box equals my new common denominator, which is 12. And I'll solve. 4 times what is 12? 4 times 3 equals 12. Whatever I do on the bottom, I must do on the top. 1 times 3 equals 3. So I'll go back and I will cross out my 1/4 and change it to 3/12. Look at my last fraction, 1/6. Oh, I need to change that too. So I'll write down 1/6 with my window box equals, and my common denominator is 12. Now I solve. 6 times what equals 12? 6 times 2 equals 12. Whatever I do on the bottom, I must do on the top. So I have times 2, and 1 times 2 equals 2. So I'll cross out my 1/6 and change it to the 2/12. Let's rewrite this new problem under solve that has all common denominators. 1 minus 4/12 minus 3/12 minus 2/12 equals f. And now I'm ready to solve. I'm going to want a nice long column so I can go straight down. So I have my 1 minus 4/12. Cross that out so I know I used it. Okay, if I have no little pieces, can I give you 4 little pieces? Nope. So I have to borrow. Cross out the 1, make it a 0. What am I going to break that Hershey bar into? Well, my denominator tells me 12ths. I have all of them, so I'm breaking it to 12/12. Now I can subtract. Common denominator is 12. I subtract 12 minus 4 equals 8, so I have 8/12. 0 minus 0 equals 0. Okay, in my solve, the next thing is minus 3/12. Line up my fractions. Cross it out so I know I used it. 8/12 minus 3/12. If I have 8, can I give you 3? Yes, I can. I will have 5 left. So that's going to be 5/12. And 0 minus nothing is 0, so I'm not going to bother writing it. I could, but I'm just not going to bother. I have one more part left here in my solve, which is minus 2/12. So I'll write down minus 2/12. I'll cross it out. 5/12 minus 2/12. Well, 5 minus 2 is 3, and my denominator is 12, so that makes 3/12. What do I have left in my solve? Equals f, so I can add it right here, equals f. My answer is 3/12. Remember, however, this is a word problem, so we need to go back to my question and find the unit. The question said, what fraction of her weekly allowance is left? Well, I know my fraction is 3/12. It's for her weekly allowance, so 3/12 of her weekly allowance is left. And that's my final answer. Please stop the video and complete worksheet number 2 right now. So let's review. When given the total and one or more parts of it and asked to find the last part, it's helpful to use the strategy work backward. The steps for work backward are set up. We have the letter of the unknown. Everything else that you do know equals the given total. Then we have work backward. We do the opposite order, the opposite operations, and the unknown letter goes at the end after the equal sign. And finally we have the solve. We solve for the work backward problem to find the unknown letter. Remember, in order to do that, if it's adding or subtracting, you must find common denominators first. And remember, frequently with fractions, you'll find a problem where you'll kind of be scratching your head and saying, I have no idea what to do here. It doesn't tell me what my total is or what to start with. Remember, fractions are part of a whole. So if it doesn't give you a total, think about, could the total be one whole thing that we're talking about? Like in example number 2 is her one whole allowance, and one whole is the number 1. Again, these are long, time-consuming problems. Again, I am going to say you do know how to solve every single step. Just take it one step at a time and work slowly. Hopefully by now, or at the very least after practice in class, you can confidently say, I can use the work backwards strategy to help solve problems with fractions that involve addition and subtraction. As always, if you have any difficulty, see a teacher. We will sit with you and help you through this. Good luck with the lesson.